We talked about this last time, right? The cerebral palsy. And the technique that the surgeons are using is they do surgery and they reattach the muscles to different locations in order to eliminate the stiffness, the tone of the muscle. So the movement of these, kids is just like, they can't have, full extension in the joints. And to us, as biomedical engineers, we would like to build robotics to help them do exercise and training, and you can study their movement and teach them to perform a motor task differently from what they're used to. And I'm going to show you a couple of examples about that. If you look at this lab here, see these infrared cameras. We have 8 of them in the human motion analysis lab, and we're going to visit that. And this is a treadmill that has, a force plate. We have see these blocks here, the boxes. Those are the 2 force plates that we can use to measure. Do you remember what we measure from force plates? Forces, X, Y, and Z, and moment as well. So the moment is force multiplied by the distance, where the center of mass is for the body. People will hire you to operate a device like these ones, or a system, collect data, store the data, analyze the data, and then extract useful clinical information from the data. You want to do prosthetics, you want to assess your prosthetic performance. This is the way how we do it quantitatively, right? With using technology and systems. I'm hoping in the future that we can convince these clinics to have at least a room that has force plates and cameras. They don't have to be infrared cameras. They can be high-speed cameras, and you can use Canovia, similar to what we will be using now. If you design anything, if you want to assess anything, just walking on the force plates could give you an indication of how the stability of the forces and the moments when someone is doing that. So hopefully the future is here and we can see this coming true. Now, this relates to you as well. Designing prosthetic limbs, especially lower limbs and feet. And what we would like to do is to design prosthetics that they can store mechanical energy and then release it to improve performance. That's something that we would like to have. And that's something that is addressed by us as biomedical engineers. So you probably know now how to develop SolidWorks, and there is a software called ANSYS. So you can build your model and render it in 3 dimensions, and then you can do mechanical testing on that model. And you can see how much force is absorbed, how much force is released at each time when we do something like that. So this is another important aspect of our work. If you want to really see how we should be moving, look at a kid 4 years old and younger. We're designed to stand and lay down. We're not designed to sit on chairs. So our habits and behavior changes our posture, what we're doing. And that's going to cause 2 things. One of them is that we have the biggest problem is the back pain, lower back pain, which is a huge problem for us and with our aging population. And the other thing, losing the cartilage, arthritis. Now, these 2 problems comes because we are not using the right posture when we move. And this is a huge field of research, and we call this occupational biomechanics. Do you know what the difference between physical therapy and occupational therapy? So physical therapy is to help you move if you lost your locomotion. Occupational therapy helps you to perform a job. So let's say someone has both hands amputated and they want to type on the computer. What kind of technologies we can develop for them to be able to use the computer? So we can use the eyes and the movement of the eye to control typing and audio as well, audio recognition. That's called occupational therapy. Manufacturers and health insurance companies will sponsor you to find technologies to help people with disability to have an occupation and to be comfortable and not have complications as we move on. So this is a big focus as well to prevent work-related injuries, especially slipping, because that's another cause of fractures for people. I know labs, biomedical engineering labs, if you're interested in masters and PhD, they have harnesses in the ceiling, and people wear them, and they intentionally get do slipping and sliding, and they study how people fall. So balance studies and analysis, that's another important aspect for biomedical engineering. Condition worker performance, causes of study-related low back pain. That's back pain is a mess. Is a big mess, and people just do qualitative analysis, nothing scientific, nothing quantitative about it. So that's another field for us to focus on. Another one is we have something called stress fractures, especially for athletes who do skating. And what do we mean by stress fracture is that, they're performing their motor whatever they're doing, and suddenly they have a fracture because of the stress. So people are now studying this mechanically, and we have companies that start developing something we call a hinge ankle skates and stuff. So to protect your ankle and also to allow it to move so that you release the stress from the hip and the knee. I've seen people do damage to their knees and hips because of this. And that's becoming, so wearables is becoming a huge field also for biomedical engineering. Sport is very important to the way of life, and unfortunately young people get injured and then they stop doing sport, and that's could affect their mental health and stuff. So that's not a good thing to have. Now our job always as biomedical engineers is to try to use technology to prevent injury. That's first, and then improve performance. So if someone is injured, can they go back to at least improving their performance? Stress fractures, it's a big thing. And behind every challenge, there is a hidden opportunity. And that's how I see things for biomedical engineering. But again, we will talk about where you should search for jobs, because I think people are doing it the wrong way. They don't know how to do this. And that's why they keep complaining that, we don't have jobs and stuff, but that's not true. Another thing is aerodynamics, and we're going to learn about this in this class toward the end of the class. What are the forces, the lift force and the drag force, and how they are affecting performance, and how can we design, let's say, wearables for clothing, helmets, and also even the bikes themselves, the cycles. How can we design them to reduce drag force and lift force so that we don't have to improve performance? Right, that's a very important thing that we do. Nike, they have one of the biggest or largest human motion analysis labs in the country, and they test all their wearables. And now they are getting into 3D printing. So now they build custom-made shoes for people using 3D printing. So an athlete comes there, especially rich big guys. So they come to the Nike and they do take some measurements in motion analysis and forces, and then they developed a custom-made 3D printed shoes for them. So that's becoming a huge field as well for us in biomedical engineering. Any sport company you can apply to, especially in research and development. So that's something you need to keep in mind as well. Motorcycles, cars, all of them. It's anything that has interaction with a human. That's a biomedical engineering technology that we need to. Another thing is to contribute to performance. And one of the examples that I keep telling people that we would like to analyze and analyze performance and then try to find a way to optimize it. And if people are healthy, and we should not intervene. If someone is healthy and doing their job, that's perfect. What we're trying to be innovative in, if you have someone that has an amputation, and then you would like to design something for them to improve their performance or optimize their performance. So this is a biomedical engineering device that was made for this athlete in order to be able to perform the sport that they want to do. And the angles and the number of these rods that have been designed and how the lengths of them, it was optimized for his upper extremity, so that he can perform the maximum performance that he can do. We have something called Paralympic Games, just like the Olympic Games for people with disability, and governments are putting so much money in for these teams. To us, you are trained to do mechanical analysis and what the laws and the formulas that we want to use. So usually when you do play tennis for the serve, what we see is that someone will put one of the foot in front and then do the serve, right? So this lady got injured, and because of the injury, her performance went way down. Can we improve her performance to go back to normal after the injury? So if you are doing something like this, that we call initial configuration, and when you do the serve, that's final configuration. And so we wanted to do something different to see, can we modify the technique that she's using to improve the performance? Instead of doing the serve like this, standing here on this, so let's say this is the line, you put your foot in front and you do that. To utilize initial configuration, put both feet on the line, and then utilize the gravity to do the serve. And she was the champion in New Jersey for 2 years after doing this, because of that. And so one of the things that you need to keep in mind is that how do you position yourself? And that's one thing we need to teach athletes. The second thing, can we utilize the gravity? Keep in mind, muscles act only impulsively. So for example, if you're doing the serve, your muscle is acting at the beginning, and then the segments are moving just because of gravity. Once you understand that in biomechanics, everything is easy. Because people think, so even if when you're walking in the swing phase, your muscles are not active. It's just the gravity that is moving the segments for the movement. And that's why our body is optimized, because we want to reduce energy consumption. So what we teach in biomechanics is that, can you understand the configuration between the first one and the second one, and can you utilize the gravity? Elderly people, they lose capability to walk, right? Sometime after stroke. So what we teach them is we want them to push their upper body forward and then make the gravity pull the legs. So always keep in mind that you need to understand two things: configuration and the role of gravity. If you know how to utilize these for any motor task, you will have the best innovations. Configuration and gravity. That's the key for the success in this field for all of us. And then you can modify the technique to improve performance. Period. Golf is also a big area for biomechanics analysis and for biomedical engineers. And it's the most expensive sport in the world. There's a lot of money there. So that's another thing. If you can be collaborating with a coach, or a coach with a famous player collaborate with an analysis lab, you'll be set for life. So we can do computerized biomechanics analysis of the golf swing, design of the balls, and all of these things. We study those as biomedical engineers because we're interacting with the human with the human body. Your role is to optimize distance and accuracy of the shots, and that all comes down actually to the center of rotation and how much. When are you activating your muscles? Always remember, the muscles should be active impulsively, and then you need your position in a place that allows the gravity to take over. That's the key for a skillful athlete in performing what they're doing. This gets harder if you have prosthetics, because now you have another variable with you, which is the weight of the prosthetic, the design of it, the degrees of freedom, the joints, how they are moving. So that's adding also more complexity to the performance. Also, wearables, not just for people to prevent stress fractures, but in general, all these sport tools and wearables are getting redesigned and moved to optimize performance. So we have 14 of these problems. Here's what I want you to do. The first task for the day. I want you to select 3 of them, and I want you to list what kind of skill right now do you have that can help in solving that problem. Select 3 of them, and 1 or 2 sentences about for each one of them about what kind of skill do you have right now that can help in that field. And we will take 15 minutes to do this exercise. Yeah, so we have 14. Pick and choose, and remember, what is the skill that you have right now that can help in such problem, Yeah, I wanted to go through all of these at the beginning, early beginning, just to make sure that what we're going to be learning, why are we learning it, And these are the applications and the problems that we are trying to solve through the tools and the skills that you will be learning from this class. So, to summarize, why are we studying biomechanics? We are trying to, apply the, principles by the scientists and professionals in a number of fields and problems. We looked at 14 of them. There are more, right? But those are the most important ones that I keep saying to people. They're promising for you to focus, to spend time and energy on them. And keep in mind, anything you do as an engineer, your mindset should be that you want to have a patent at the end. So if you have a new design, if you have a new protocol, or a new, let's say, code, software, program, your mentality should be that this is patentable and I would like to patent it. Now, you can, if whatever idea you have, if you really feel that's really good, you can have something called provisional patent. You protect your idea for 1 year. During that year, within that year, you can sell the patent to someone else, or you can leverage on it and file a full patent. So keep that in mind, because especially in our field, everything you do is the first time being done. I have a patent, and I did it because of my PhD work, but I keep seeing a lot of projects, very good ideas, but the students, they don't go ahead and protect these ideas. Companies, so if I have a patent, let's say for shoes, something to improve performance or whatever in a shoes, I can file a provisional patent, reach out to Nike, I tell them I will break you down with my patent. And to them, it doesn't matter. They don't want to understand it. They just want to buy it, and nobody is going to compete with them. And if really, you have some, reputation behind you, they will buy it from you, and they tell you, oh, we don't want to build it. We put it in the drawer, and that's it. We're done. So big companies, Stryker, Johnson & Johnson, any name, they have in their drawers hundreds, if not thousands, of patents, just so that nobody is competing with them. That's how they leverage on, and how we as engineers leverage in this field. So keep that in your mind. So we have problems. The difference between us and mechanical engineers is that we are dealing with designing products and devices that interact with biological systems or the human body. That's it. And because of your training in biology and anatomy and physiology, you know more about the human body than mechanical engineers or civil engineers or other electrical engineers. And that's the key for our work. Related to human health and performance, I like to improve performance for people with disease conditions or disabilities. I don't like to intervene with someone who is healthy. That's my opinion. I don't like to improve. I think the human body is optimized unless you have an injury, and then we will intervene. That's how I look at it. We need knowledge of basic biomechanics concepts. So we learn it as engineers, but also biomechanics, the concepts, is good for physical education teachers, physical therapists. We have a PhD program in physical therapy. We can collaborate with them. Physicians, we have an assistant physician program at Mount Union. We can collaborate with them as well. And you have coaches. We have a lot of coaches at Mount Union, personal trainers and exercise instructors. All of them can benefit from the technology you can bring to them. We talked about qualitative and quantitative analysis, and we have an idea. Quantitative, you need to give me a number and a unit. You need to compare things. Qualitative is something from experience, and someone will tell you, oh, you are strong, or you are fast, or you are good in doing that. To us, in engineering, it means nothing to me. Give me the numbers, because that's what I understand. Yeah, you need to give me a number and a unit. That's quantitative. If you have a robot, someone will say, oh, the robot missed the coffee by 15 centimeters, and someone will tell you it's malfunction. Come on, what does that mean? You need to give me what is the thing that went wrong so that I can fix it, right? And that's an example of robots. The same thing goes for humans. Tell me what is the thing that is not working, so that we can act on it and try to quantify the progress. Coaches, but we need to work with them and tell them that you need to be relying on more quantitative than qualitative things, and it's a process to work with them. I have collaboration with exercise science faculty, and we worked with the women basketball team last year because of the ACL tears. So we had them jumping from a box on the ground and jumping on the force plate, and we looked at how the forces changed because of doing this, or they're doing that, compared to male, athletes. So we are telling them that this is simple. We have the tools. We can benefit from it and publish, and study what's going on. So that was fun. I encourage also you to think about an idea if you're interested in this, and we can do it. We have a lot of data that can be collected from the students. They don't know how to analyze it. So that's where we come in. Does that make sense? So we are the people who can collect the information and extract and filter. So if you want to formulate, we have formal problems and informal problems. Formal problems, I can tell you, I would like you to measure the moment of a force arm. That's the value of it. So everything is set, clear, and you're going to use a mathematical formula. Informal, things that, how can I, become the captain of the basketball team? I can't help you with that. So give me numbers. Tell me how can I improve, the stability index for me when I do the free shot, right? I have now a problem to work with. We know what we want to do, and I have an idea about how to assess it, and it's repeatable. Now, you've seen this in the statistics and dynamics of how do you solve a quantitative problem. You need to have, read the problem first. What are the things that are given to you? I need the weight of the subject. I need the height of the subject. I need to have the distance between, let's say for the basketball, distance between the subject and the ring, right? I need to know the weight of the basketball. And you can tell me what is the speed of the ball when it comes inside the ring. I can calculate that, right? Because I have the inputs. I can draw free body diagrams. That's very important for us as engineers to have. And then we have the formulas. You put the knowns in the formula, or you infer if there's something missing. You substitute, you solve, and you check with common sense, and then you add your numbers and your units. That's how we do our job. Yeah, make sure that you have units. So we have two different types of units. You have international, the SI unit, and then you have US custom system, and which is pounds and kilograms. And what I want from you to do today is to try to do an exercise in the last 5 minutes or so of our lecture. Can you convert these into numbers, into the correct unit? And do you remember what is the three significant figure? What is the three significant figures that you should have, So what is this? So 1.25. So that's three significant figures, right? So if you have 1.257, that's not three significant figures. That should be 1.26, right? 100.1 should be 100, right? So three significant figures, it means that you have three numbers in your. So I want you to do the conversions, just to, get ourselves into the mathematics again, and to get back familiar to the units. This is a table that has the conversions. If you want to use it, it'll make things simpler to you. And make sure that we are, kN kilonewtons is 1,000 Newton, right? So make sure that you have that conversion correctly. Yeah, add your names, your date, today's date, and see if we can get those completed.